Welcome. This screencast is going to go over the solutions to the Chapter 3 test. So the first question asks, which statements about the periodic table are correct? And number 1 says the elements Mg, Ca, and Sr have similar chemical properties. And if you look, you see that all three of those are in the same group or family, so that's a true statement. Number 2 says elements in the same period have the same number of main energy levels. That's also a true statement. That's how periods or rows are organized. And it says the oxides of Na, Mg, and P are basic. That's true for sodium and magnesium, but P, remember, is going to tend to combine with hydrogen, as in the case of H3PO4. So that is not true. So that means 1 and 2 only, or letter A is my correct statement. Number 2 asks, which series is arranged in order of increasing radius, Ca2 plus, Cl minus, or K plus? And what you're supposed to notice is that Ca2 plus means that you have number 20 calcium and it only has 18 electrons, but it still has its 20 protons. Whereas with Cl minus also has 18 electrons, but it has a 17 plus nucleus, whereas K plus has 18 electrons, and it has a 19 plus nucleus. So you've got the same number of electrons, so the same configuration being held with a plus 20, plus 17, and plus 19 nucleus. So increasing radius, this would be my biggest one here. This would be my smallest here, so it's going to be Ca2 plus, and then K plus, and then Cl minus, or letter C. 20, 19, 17. Number 3 wants to know which ion has the largest radius. So Cl minus is in period 3. Br minus is in period 4. And F minus is in period 2. I don't even have to consider the K plus because negative ions are always bigger than positive ions. And so these each have picked up 1 electron. That means the period 4, or bromine minus, is going to be my largest ion. Number 4 wants to know which statements about period 3 are correct. The electronegativity of the elements increase across period 3. That's true because elements get smaller as you move across a period, which means they're more electronegative. Number 2, the atomic radii of the elements decrease across period 3. That's also true. That's why they become more electronegative. And the oxides of the elements change from acidic to basic, and that's just backwards. Metals are going to tend to pick up the OH, or the hydroxide, whereas the nonmetals will pick up the H+. So they've got that just reversed, meaning that A, 1 and 2 only, are correct. Number 5 wants to know which property decreases down group 7. So group 7 is the halogens. The first one is melting point, and that's actually going to increase down group 7 because there's going to be more energy levels and more electrons giving opportunity for more van der Waals forces, not to mention there's going to be an increase in molar mass. Electronegativity, that will decrease down group 7. Atomic radius is going to increase as you add an energy level, which means ionic radius will increase also. So B is the only one of those trends that decreases down group 7 in the periodic table. And this actually, they mean 7A or group 17. That was not a well-written question in regards to the numbering there. Number 6 asks, which equation best represents the first ionization energy of magnesium? Well, remember, ionization energy, it has to be a gaseous element, so A and D are automatically eliminated. And electrons can only be peeled off one at a time, so that leaves only C as being a possibility there. Number 7 wants to know which properties of the alkali metals decrease going down group 1. And A says first ionization energy and reactivity. Well, those both actually, first ionization energy does decrease as the atoms get bigger, but the reactivity increases because the atoms are bigger and more likely to lose those electrons. Melting point decreases as the electrons move further and further out, and atomic radius increases as you add an energy level. Reactivity, as we already said, is going to increase, even though electronegativity decreases. But finally, first ionization energy and melting point both decrease as the atomic size or radius increases. So D would be my correct choice. Okay, so that concludes the 7 multiple choice questions, or the paper 1 type questions. And as a class, we did pretty well on the multiple choice. The paper 2 free response questions, kind of all over the board on this. So let's look at what you were supposed to do. Number 8, they gave you a surprisingly small amount of space for something worth 3 marks, and if you read carefully what they're asking for, they want to know the acid-base character of oxides from Na to argon. So this one, you had to indicate that it would be acidic for sodium, magnesium, and you can include aluminum with that if you want. You had to mention it's going to be amphoteric for silicon. And aluminum could be in this group as well, but silicon for sure is amphoteric. You had to mention it's going to be basic for phosphorus, sulfur, and chlorine. And you had to mention there's going to be no reaction for argon. So you had all 4 of those to mention for your first mark. Then you're supposed to write a balanced equation for NaO, Na2O, and sulfur trioxide. And remember, these are just going to be Na2O plus H2O is just going to be a synthesis equation to yield 2NaOH, whereas SO3 plus H2O, oops, I need the plus there, SO3 plus H2O is also going to be a synthesis to yield H2SO4, and those were each worth a mark. Number 9 says, consider the bonding and structure of the period 3 elements. Explain the increase in melting point from sodium to aluminum. So this is Na to Al, both metals. So basically they're asking, why would there be a difference in melting point for sodium and aluminum, and how does it relate to the bonding and or the structure of these 2 elements? So they're both metallic bonds. And what they wanted you to realize is a metallic bond is between the positive cation, which is your nucleus and inner electrons, attracting the delocalized electrons. And so what you're supposed to realize is sodium is larger with 1 valence electron, whereas aluminum is going to be smaller with 3 valence electrons. That's going to mean these 3 valence electrons are going to be held much tighter to the smaller aluminum. Plus, for every aluminum ion, I've got the aluminum cation here, actually a 3 plus, and it's going to be it's going to have 3 valence electrons per atom that it's making these attractions or these electrostatic forces are arising between. And then I've got the larger plus 1 sodium with only 1 valence electron or 1 delocalized electron per atom to be making those attractive forces with. So melting point should be significantly higher for the smaller, greater number of valence electrons found in aluminum. Part B asks, why sulfur 8 has a higher melting point than phosphorus 4? Well, sulfur 8 is actually the smaller atom. P4 is a slightly larger atom. So the smaller atom is going to allow S8 to pull things in a little tighter. And the other big thing is there's 8 atoms per molecule, whereas with P4 there's only 4 atoms per molecule. And since this is all about van der Waals forces, there's going to be a lot more temporary dipoles possible when you have 8 atoms and all those bonds in S8 versus much fewer atoms in the P4. And then C, explain why silicon has the highest melting point and argon has the lowest. Silicone, all they were looking for, you didn't have to go into a lot of detail, but silicone forms a giant covalent structure. And since these are worth just 1 mark each for a total of 2, that's all you had to say, giant covalent network or giant covalent structure. And argon has the lowest melting point because they're monoatomic. So there's no bonds, which means there's very few London dispersion forces, or LDFs, that are going to occur. Very few opportunities for any kind of a temporary dipole. Define the term first ionization energy. For 2 marks, they're looking for really about 4 different ideas. It's energy, and it's energy to remove an electron. So those are the first 2 keywords they're looking for. And then it's from 1 mole, and it has to be of a gaseous element. So kind of a half mark apiece for those 4 key ideas. Number 2 from question number 10 wants to know why the first ionization energy of magnesium is higher than that of sodium. Well, if you look, Na is number 11. So it's got a +1 effective nuclear charge, and it's got 1 valence electron, whereas Mg is number 12, so it has a +2 effective nuclear charge, and it's got 2 valence electrons. So magnesium is going to have a stronger nucleus, it's going to have a smaller radius because of that, and it's going to have 2 valence electrons per cation to set up those electrostatic attractions. And those are the reasons why it's going to have a higher first ionization energy, or it'd be harder to remove that first electron from. Number 11 says, describe and explain what you will see if chlorine gas is bubbled through a solution of potassium iodide, so this is Ki, or potassium fluoride, this is Kf, and chlorine gas is Cl2. So really what you're talking about here is, will this single replacement reaction happen? And for it to happen, chlorine has to bump off either iodine or fluorine. If you look at your periodic table, if you don't remember the reactivity of the halogens, although I'm guessing most of you remember fluorine's the most reactive, upper right holds them tight. It's the smallest, most reactive element. So chlorine being below fluorine is not going to be able to knock fluorine off, but it will be able to knock off the bigger iodine. So this will have a reaction to give you KCl and I2, and you need a 2 here and a 2 here to balance that. That will happen. So what will you see? You'll see a color change, or you'll see it turn yellow. You'll see a yellow solution. And the reason why is because chlorine is more reactive than iodine. With potassium fluoride, you'll see nothing. There'll be no reaction because fluorine is more reactive than chlorine. Now, your hint as to, when you look at this, you should have realized one's going to react and one isn't, especially if you look at the halogen family. Chlorine's between fluorine and iodine, so it can't be more reactive than both. Reactivity either increases or decreases. And if you weren't sure which way it went, one's worth 2 marks and the other one's worth 1 mark. The one that actually changes is the one worth 2 marks. So some savvy test taking would help you come up with a good choice on these, even when you're not sure what they're asking for and not sure if you remember it. Number 12, this is one where I'm just not sure it's worth working that hard to remember the equations, but sodium with water, this one's not too difficult. You have Na, the sodium, you have water, and if you remember, it's going to be vigorous, and it's called an alkaline metal, so you know it's going to form NaOH, and there's a lot of bubbling going on, so there's a gas being produced, which happens to be hydrogen. So then if you balance that, you need a 2 here to make it balance. So that equation's not too bad. Your state symbols, it's solid sodium, water's a liquid, this is going to be aqueous, it's going to remain dissolved, and this is going to be a gas. So that's what you need to pick up the 2 marks for 12A. 12B says, with reference to electron arrangements, suggest why the reaction between rubidium and water is more vigorous than sodium and water. Well, the electron arrangement for both is, we're talking about an s1 orbital, 3s1 versus 5s1. So they both have one valence electron, which makes them highly reactive, being in family 1A, because they're the largest and have the lowest ionization energies of all the metals. But this 5s is what lets us know rubidium is much bigger, so the electrons are that much looser. The ionization energy is that much lower, making it a more vigorous reaction. Number 13, part 1 says, outline 2 reasons why sodium ion has a smaller radius than a sodium atom. Well, a sodium atom